Alright, let's move on then to number 5, where we've been given two different situations when renting a motorbike. So it costs $30 for the first hour, and then $8 for each additional hour. So how much will it cost if you get it for 2 hours? Well, it's $30 for the first hour, and $8 for that second hour, so that's going to be $38. For 3 hours, we're going to take our $30 for the first hour, and then we're going to be adding 2 additional hours of $8 to give you a total of $46. You'll see that, by the way, well, let's keep doing this. Let's go with part B. Now we're taking our $30 for the first hour, and how many different 8s are we adding? There's 11 additional hours at $8 per hour. That equals 30 plus 88, and that's equal to $118. So let's move on then to part C. It gives us a different situation, because of course the more hours we rent the motorcycle, the more expensive it becomes. So the motorbike can also be rented daily at a special rate of $160. That's for the entire day. 24 hours, I guess I get it. Calculate the least number of hours that the motorbike must be rented so that the special rate of $160 is cheaper than paying per hour. Now remember when we were paying per hour, we were paying $30 for the first hour, and then remember when it was for 12 hours we added 11 of the 8s, and when it was for 3 hours we added 2. It's all of the additional hours. So if you've got it for n hours, then it's 30 for the first hour, it's n minus 1 times 8 to represent the number of additional hours that you are being charged at 8 each. So let's solve that equation. We can type into y equals 160 as the left-hand side of the equation. And in the second equation, we can type in 30 plus x minus 1 times 8. And do I expect n to be an integer? I think so, because it says $8 for each additional hour. It doesn't say that you can pay less for a part of an hour. So I think that we should look at the table. I'm just going to set up my table so that it begins again at 0 hours and goes up by 1s. Yes, that looks good. So second graph for the table. And let's see, where is my special rate less than the hourly rate? And we see that that finally occurs when we get to, there it is, 18 hours is when finally the special rate is a better deal than the hourly rate. So to show this work, we'll say y1 was equal to the left-hand side, y2 is equal to 30 plus x minus 1 times 8, and then we'll make a table, x, y1, y2, and we'll indicate only the 2 rows where I wasn't quite cheap enough, and then where finally 160 was cheaper than the hourly rate, and that occurred when n was 18. Thus, your answer is 18 hours must be the least number of hours. Number 6, we've been given an arithmetic sequence. We need to find the value of a. Now, if it's arithmetic, we know that the differences are the same. So a minus 3 must be the same as 10 minus a. They must both equal the common difference if it is truly an arithmetic sequence. Alright, so let's bring the negative a to the left-hand side. It becomes a positive a. And the negative 3, let's move to the right-hand side where it becomes a positive 3. You'll discover that 2a is equal to 13, and thus a is equal to 6.5. Let's write down the common difference. Well, now look at your first 3 terms. 3, 6.5, 10, and so on. And so our common difference can be found by taking differences of terms. 6.5 minus 3 gives you 3.5. 10 minus 6.5 gives you 3.5. You can see that your common difference is equal to 3.5. Now we need to find part B. Well, if I'm increasing by 3.5 every single iteration, then 10 must add 3.5 in order to get my next term. Another way you could have done this is said, look, b minus 10, the difference between these two terms, should give me my common difference of 3.5. And thus, if I bring the negative 10 to the right-hand side, I can see that I get 13.5 for b. And lastly, it asks for the 11th term. So it wants u11, which I know is u1 times, plus 11 minus 1 times d. So let's fill in what we know. We know that u1 can be seen as 3. 11 minus 1 is 10. And we can see that d, the common difference, is 3.5. And when you evaluate that, it becomes 3 plus 35. Thus, u11 is equal to 38. Let's go on down to number 7. All right, we need to calculate the sum of all of these 12 terms. All right, the sum of these 12 terms. Let's first figure out whether it's an arithmetic or a geometric sequence. 9 over 4 minus 3 will give you negative 0.75. 27 over 16 minus 9 over 4. Gosh, I can't do that one, so let's try it. 27 over 16 minus 9 over 4 gives me a totally different number, negative 0.5625. So it's not arithmetic. Let's try geometric now. So I've got 9 over 4 divided by 3. So let's see, 9 over 4 divided by 3 gives me 0.75. And then I've got 27 over 16 divided by 9 over 4. That's like multiplying by the reciprocal, but I can do it here on the calculator. I'm just going to put each fraction into parentheses. 27 divided by 16 divided by 9 over 4 gives me, hey, again, 0.75. So clearly this is a geometric sequence. And so it wants us now to calculate the sum of this geometric sequence to 12 terms. It wants S12. So in the geometric sum formula, I've got u1, which I can see as 3, and then r to the power of n. Our r is 0.75 raised to the power of n, which is 12. Subtract 1 over r minus 1. So here we go. 3 times 0.75 to the power of 12, exit the exponent, minus 1, close the parentheses, divide by the entire denominator of 0.75 minus 1. Oh, damn it. Hope that worked. I forgot to close the parentheses at the end, so I'm just going to bring up the last entry, second entry, and let's add that parentheses at the end in case it changed things. No, good, it didn't. So my answer is 11.61988. And you can write that down and get full credit. As long as you include additional significant figures, you're fine. But if you like 3 significant figures, that rounds to 11.6. Number 8. 3 consecutive terms of an arithmetic sequence are these 3. So if they are in an arithmetic sequence, the second term minus the first term must give us the common difference. The third term minus the second term must give us the common difference. So I'm just underlining the 3 terms. They're slightly more complicated algebraic expressions. But the point is that the difference between each pair of terms should be common, should be a common difference. Meaning then that 3 plus 4k minus 3k plus 1 should be equal to the difference between the other 2 terms, 7k minus 1 minus the second term, 3 plus 4k. Now, my minus must distribute to both parts in each side of the equation. And so my next line becomes 3 plus 4k minus 3k minus 1 equals 7k minus 1 minus 3 minus 4k. I'll simplify each side now. That gives me a k plus 2 over there, and it gives me a 3k minus 4 on the right-hand side. Let's bring the k's together. If this 3k moves to this side, it becomes a negative 3k. So our k minus 3k. Meanwhile, if this plus 2 moves to the right-hand side, it becomes a minus 2. So I've got negative 2k equals negative 6. Let's divide each side by negative 2, and we find that k is equal to 3. So part B says write down the values of the three terms. Well, look, if k is 3, I've got 3 times 3 plus 1, that's 10. 3 plus 4 times 3, that's 3 plus 12, that equals 15. And the third term, 7 times 3, 21 minus 1 is 20. And look, they do form an arithmetic sequence, 10, 15, 20, where your common difference we can see is 5, your first term is 10, etc., etc. Alright, and we'll finish this worksheet off on the next video.